Which of the following is an alloy? Actually, what do you mean by alloy, children? Yeah, Neha is correct. Very good, Neha. Swamika wrong, Pragya is wrong. Okay, so which of the following is an alloy? What do you mean by alloy, children? Alloy is a mixture of different things and homogeneous mixture of different metals or non-metals. Alloy is a homogeneous mixture of metals or non-metals. So why to prepare alloys? So 90%
there is a copper or alloy also.
Copper is not an alloy.
Ma'am, can I say on the net? But the net also says the same thing because I knew that it.
Copper is not an alloy. Copper is involved to prepare alloys. Copper is a pure metal.
Ma'am, can I say why stainless steel is an alloy?
Yeah, I will. I give time. Let me explain the thing. So why copper is an alloy? Tell me first. In what sense copper is an alloy? Copper is not available within 118 elements in the periodic table. Yeah. How can you prepare copper?
Ma'am, I couldn't understand what you said.
In what sense you said that copper is an alloy?
Ma'am, actually I learned it and then why? Because I wanted to be sure I checked on the internet also. But they said that copper is like, they say that the best known traditional types are bronze, where tin is a significant addition and brass using zinc instead. Today the term copper alloy tends to be substituted, especially by
Yes, Monica, can you understand what you are reading? Copper is not an alloy. Copper will participate in formation of alloy. Like brass is the combination of zinc and copper.
Okay, ma'am.
Understood. Brass is obtained from zinc and combination of zinc and copper. 30% of zinc and 70% of copper. How can we say that copper is an alloy? Copper is a pure metal, like iron is a pure metal, gold is a pure metal, and copper is also considered as a pure metal. Understood? So in order to enhance the quality of copper, brass is obtained along with the zinc. Understood? We can't say that copper is an alloy. Copper participated to form alloys. Okay, it's one of the composition or component in brass. Brass, here stainless steel is an alloy. Tin and what are the combinations of stainless steel?
Ma'am, yeah, steel and stainless substance, I think so.
Understood or not? So second question, which of the following methods would you use for separating pulse seeds from rice? Which of the following methods would you use for separating pulse seeds from rice? So which one is the correct answer? So Neha said the answer hand picking. Yes, it's correct. Pragya also said. Yes, very good. Why? Because so the rice when it is mixed up with grains, so it is easy so that we can see the size of the particles and we can easily separate by using our hand. So hand picking is the best method to separate the components. Which of the following methods would you use for separating iron from sulfur particles? The options are magnetic separation, filtration, churning, distillation. Yes, Pragya said the answer first. Magnetic separation.
Ma'am, I have put all the 4 answers together.
Yes. Very good, Neha. Very good. Very good. Okay, which of the following methods would you use to separate iron and sulfur? Here, in case of iron and sulfur, why sieving? Why sieving, Chet?
Ma'am, I gave for the 4th question.
Yeah. No need to answer it. Let us discuss. Okay, remaining children, I think Fawaz did not attend to the previous session. Okay, so let us discuss. So in case of magnetic separation, the answer is magnetic separation. Why? Because here iron and sulfur, when we mix up iron and sulfur, iron is a magnetic substance. So here iron can be separated from sulfur not by filtration because both cannot dissolve in water. Okay, churning means we'll churn it to remove the cream from milk. That is churning. And distillation process is to separate the ions present in water or any other liquids. So all the three are not used in separating the iron and sulfur. So we go with magnetic separation. When we place a magnet near to the iron and sulfur, the iron is easily attracted towards the magnet. Why? Because it's a magnetic substance. Understood or not? Next. Which of the following methods would you use for separating stones from sand at construction sites? At construction sites. Understood? At construction sites, we can see that they'll separate the sand from the pebbles. Okay, they'll use a big, wide sieving thing and they'll pour the sand on it and they'll allow it by using wood or any other like like a solid. They'll separate the hard pebbles from the sand. So we get a clean sand. The sand is used to construct the walls along with the binding agent. Here, binding agent is nothing but a cement. Yes or no? So here the answer is sieving. Winnowing cannot be used, hand picking cannot be used, and distillation also cannot be used here. Next question. Which of the following is the drawback of decantation technique? Option A, it is useful in the separation of the clay. It is used in the separation of the clay and sand particles from the muddy water. The constituents of the solid lighter than liquid cannot be separated as the floats on the surface of the liquid rather than settles down. One of the components is heavier than the liquid and it is insoluble. The constituents of the mixture of the solid and the liquid do not get separated completely. So what will be the answer, children?
Ma'am, why it is a drawback? Because I give the answer as B, because the constituents of a solid lighter than liquid cannot be separated as the float on the surface of the liquid rather than settling down. Because more than settling down, some some particles will be out. They will also come with the water when we decant it, right?
Yeah, very good. So this is a big drawback. Only we need to select the components which are heavier than water, so that they'll rather than the floats, but they settles at the bottom of the liquid. So what happens? We can easily decant the liquid and we can separate the sediment. Okay, but if in case of solids which are lighter than water, they can't be separated by using decantation process. Understood? So this is a big drawback. So that we need to select the sedimentation and decantation where the solids are heavier than liquid, so that they can settle at the bottom, so that the sediments will be stable and we can easily decant the liquid. Distillation is the process based on the principle of differencing, melting point, sublimation, freezing point, boiling point.
It's boiling point.
Yes, it's boiling point. Based upon based upon the components which are having different boiling points. When they attain the boiling point, when the sample is continuously heated, when they attain its boiling point, that components will come out first from the distillation column. Understood? So that it is completely based on boiling point. Here distillation is especially used in what cases, children? In which sample we can select the distillation process? For which sample we need to select the distillation process? Completely
dissolved together.
Dissolved together.
Because we cannot differentiate the two liquids like that.
Yes, we can't separate the two liquids by simple physical process. So in that sense, distillation is used.
Ma'am, I want
Okay.
to ask the question like, what is crystallization?
Crystallization is nothing but it's a kind of separation technique, or it is also used for purification of crystals. Understood? So in that crystallization process, we take like if we want to crystallize copper sulfate, so we need to take the copper sulfate crystals, dissolve it in the liquid so that we get a copper sulfate solution. From the copper sulfate solution, we need to continuously heat the copper sulfate solution. Then these copper sulfate solution, the liquid content will be evaporated. Almost all the liquid content need to be evaporated. So we need to leave the sample until the 3/4 of water is left over along with the crystal. If we leave the sample to get it cooled down, so that what happened, we can see the regenerating of crystals from the copper sulfate solution. So the obtained crystals from the copper sulfate solution are purer than the copper sulfate what we have taken. Okay, the regenerating of crystals from its own crystalline salt is known as crystallization. Understood? Any doubts? Any doubt?
Ma'am, I didn't get it. Can you give me an example?
So the example is nothing but take a copper sulfate other than the copper sulfate, sodium chloride, like take seawater. From the seawater consists of sodium chloride. Along with the sodium chloride, different kinds of salts are present in it. But we want sodium chloride only. So what they'll do? They'll undergo evaporation process. After complete evaporation of liquid, we get crystals, obtaining crystals from that sample or the seawater. Understood or not?
Yeah, ma'am. Now I understood.
Yes, the formation of crystals are nothing but crystallization. Okay, or the regenerating of crystals from its own salt solution is known as crystallization. Any doubts?
No
Any
doubt,
doubt?
ma'am.
No doubts? Next. So read the following instructions to solve the given question. Statement 1. Is it true? Statement 2. Is it true? Or statement 3 is correct explanation for like as a assertion and reasoning type question, children. Okay.
Statement 1. The process of separation of two different soluble substances from the solution by crystallization at controlled temperature such that one of the solid crystals is called fractional crystallization.
Yeah.
Statement 2. The mixture of sodium nitrate and sodium chloride separated by fractional crystallization.
Separated by a fractional crystallization. Fractional crystallization is nothing but based on the crystals, like which crystals obtained first, based on its like even though it is also based on the boiling point of it. So we can say that which answer is correct here. Statement 1 is true. Statement 2 is also
True. So,
yes.
yeah. I actually wanted to say that, but I took the wrong option. Like I told statement 1 is true and the statement 2 is true. Statement 2 is a correct explanation for it.
So
I haven't
why
seen that.
Pragya, you have given C.
Ma'am,
Pragya, can you please?
why I gave wrong is because I haven't read the whole sentence.
So now we should know about fractional crystallization is like what I said, if the seawater, if you have taken the seawater, if we allow the seawater for evaporation process, the components in the salts present in the seawater is not only sodium chloride salt solution. Okay, crystallization is nothing but formation of crystals from its salt solution. Okay, this process of crystallization, or the examples for crystallization is obtaining Copper sulfate is a kind of salt, children. Copper sulfate crystals from copper sulfate, obtaining copper sulfate crystals from copper sulfate solution.
Ma'am, can you give a definition for it?
Yes, you'll be having a definition. Yes. Copper sulfate solution. Definition is nothing but, crystallization is nothing but the regeneration of crystals from its own salt solution. The regenerating the crystals from its own solution is known as crystallization, or the obtaining crystals from its own solution is known as crystallization. The two best examples we can give for crystallization is obtaining copper sulfate crystals from copper sulfate solution. One.
Ma'am, regenerating?
Regenerating means getting again from its own
No, ma'am.
crystalline
After
solution.
that, you told some definition, right? Regenerating?
Regenerating crystals from its own salt solution. From its own salt solution. At the same way, one, crystallization can also be observed in case of crystal salts. You know the crystal salt? The crystal salt is obtained from seawater. Okay, the seawater consists of different salts, different kinds of salts. Okay, so what we want is the main required salt in the seawater is nothing but crystalline NaCl, sodium chloride. So what they'll do, they'll take the seawater and they'll pass the seawater, or they pour the seawater in the shallow blocks. Just first of all, they'll take a big field. In that field, they construct different shallow blocks of different sizes, like almost uniform in measurements. Okay, they'll add the seawater and they'll allow the seawater for 2 to 3 days. Not only to more than that also. Okay, so after leaving for a few days, we can observe that we can find that regenerating, the obtaining of crystals from the seawater. That process is known as crystallization. Okay, or we can say that it's a simple evaporation process. We can observe evaporation. After evaporating the liquid, we can find a formation of crystals in that blocks. Here, like the crystallization is nothing but, here crystallization is nothing but obtaining, it's a pure form of crystals. I said, crystallization is a kind of separation technique. At the same way, it is also used to purify the salts. Yes or no? So crystallization is the process of formation of large crystals in pure state from its solution. So the crystals obtained from seawater is also a combination of different kinds of salts. So in order to purify it, they'll undergo this crystallization process. So how through fractionating crystals and nothing but if two different kinds of crystals are present in the solution. The previous module, you have observed only crystal salt is present in it. That's really easy to separate only one salt by the same process. So if it is fractionating crystallization, nothing but two different kinds of mixtures are allowed to mix up in the solution. So based on the solubility, okay, it is least soluble with the solution, that will be form first crystals, and after continuous heating and cooling down, so that what happened, the next one, so that it is highly soluble with the solution, so it takes some time to form crystals. This is known as fractionating crystallization. Yes, understood? Any doubts? Any doubts? Very good. So the option is statement 1. What is the statement 1 here? The process of separation of two different soluble crystals from solution by crystallization at controlled temperature. Yes, it's not like too high temperature, only just to evaporate some liquid just heated, such that one of the solid crystals is called fractionating crystals. Statement 2. The mixture of sodium nitrate and sodium chloride separated by fraction. Techniques or the methods of distillation, filtration, fractional distillation, evaporation, crystallization. Select and write down the techniques you would use to separate. A mixture of acetone and water. A mixture of
Distillation.
yeah,
Distillation. Simple distillation.
simple
Distillation.
distillation. Okay, or fractional distillation also we can say. Okay,
But in the video which you saw, they specifically told like simple distillation, right?
and here is there any option about simple distillation, child?
No.
So in which sense we need to go with according to the options given. So fractional distillation also can be given because I have shown you the fractional distillation tank like column in the picture when I showed you the slide. Did I?
Yeah.
Carbon disulfide and sulfur. Carbon disulfide from sulfur. Which technique is
Filtration.
yeah, filtration. Yes, filtration because sulfur won't dissolve with carbon disulfide solution. So filtration is used. Barium sulfate from water, evaporation. Okay, which of the following is separated by fractional distillation? The option is nothing but all. So all the three can be separated by using fractional distillation. So option E is correct. Am I right?
Yeah.
Understand?
Yeah.
Yes. Next. The immiscible liquid-liquid mixture separated by the immiscible
Fractional distillation.
why fractional distillation? That is the main.
Distillation.
Huh?
Distillation.
No, ma'am,
right?
sorry, not fractional distillation,
Ma'am,
distillation.
separating funnel.
Very good.